Okay, welcome back. We are going to continue in this lecture with the sensitivity analysis of an LP problem. In the previous lecture, we focused on the interpretation of the first table in the sensitivity analysis report. The first table has relevance to the objective function coefficients, and now we will focus on the second table that has relevance on the right-hand side values of our constraints. Okay, if we look at this table here, we will see that the final value column, that is the amount of the specific resources actually used. So to get maximum profit, 100,000 rands was spent. And also we used 6,39 tons of the total reservoir size of 8 tons for diesel. So we used 6,39 tons of that capacity, and for the unleaded petrol we used 5 tons of storage capacity. Then the second column, the shadow price, this is also very important. It gives the benefit or the loss we get if we change a constraint by 1 unit. For example, if we look at the shadow price for the first row, if we increase the total funds available, and the total funds available is 100,000 rands, if we increase it by 1 unit, in this case in rands, then the profit will increase by the shadow price. Now the shadow price, if I take this out, the shadow price is 0.22, so that will be 0.22 rands or 22 cents. If we increase the available funds by 100 rands, in other words 100 units, then the profit will increase by 100 times the shadow price, so that will then be 100 times 0.22, so it will increase by 22 rands. If you look here at the shadow price for unleaded petrol, then if we increase the storage capacity for unleaded petrol from 5 tons to 6 tons, then the profit will increase by 211 rands and 11 cents. Also, if we decrease the storage space for unleaded petrol from 5 to 4 tons, then the profit will decrease by 211 rands. The third column just gives us the current values of the constraints. So these are the right-hand side values of the constraints. The last two columns give us the allowable increase and allowable decrease, and that is the amount by which the constraint right-hand side is allowed to increase and decrease and yet have the current decision variables in the optimal solution. Now we call this range the range of feasibility for a constrained right-hand side, and that is interpreted as the range of values that the right-hand side can become without changing which decision variables are in the optimal solution. So to get the range of feasibility for the funds, for example, we take the constrained right-hand side for price or for funds, which is 100,000 rands, and we subtract from that the allowable decrease to get the lower limit. And then we take the 100,000 rands and we add to that the allowable increase of 14,500, and the resultant range is called the range of feasibility. So if the available funds fall between these limits, then diesel and unleaded petrol will still be in the optimal solution and petrol will still be excluded, but the values, the optimal values for X2 and X3 will be different, non-zero final values. So let's try this out in Excel. Okay, here we have again the solution to example 56. What I'm going to do now is I'm going to change the right-hand side value of the funds available. So I go to my solver and then I click on this constraint and I want to change it. And now I'm changing this constraint right hand side. First of all, I'm going to change it to a value.